So we had few talks before us, and almost in each of them, Zero-ETL was mentioned. So let's unpack it now. My name is Stas. I'm a database specialist focused on relational engines, and I accompanied by Aman. He's a DynamoDB specialist. He will be helping us to review the other part of the presentation about Zero-ETL integration. So what we're going to talk about, we will review what problem we're trying to solve with this integration, with this solution. We'll see what it's all about, how it works, and what its value proposition. And we will see how it's used by our customers and discuss it. And we have some call for action later. So it's been mentioned multiple times today that data is everything for our business. Right? So the more data we have, the more insight we can gain from it. But the data is located in different places, and we want to run almost the same analysis on all the sources of our data. Right? We want to get trend analysis, we want to take fraud, we want to understand that everything is good. So what is the challenge? Let's see with raise of hands. How many of you need to analyze data from multiple databases? Yeah? And all right, good amount of people, so you're in the right room. And who need to build multiple pipelines and maintain them for this purpose? All right. So we kind of understanding now what is the complexity, what is the problem. The data, our data sources, our operational data is located in multiple databases or data sources, and we like to move them to our analytical area. It can be data warehouse, it can be data lake, and we need to build and maintain and, of course, monitor and secure all the pipelines that transfer this data from operational side of the business to the analytical side of the business. So this is the challenge. And this is the solution that we suggested for this, and it's called Zero-ETL. So it's not one solution, it's a set of integration that can copy data, help with copying or streaming data from multiple sources to multiple destinations. We'll be reviewing them shortly. And we would like to eliminate or dramatically reduce the amount of undifferentiated work that you or your teams will be investing into this process, and to make sure that it copies the data in a secure way from database to database. So those integrations that are available currently, you can see that we have multiple sources, like for relational databases, Aurora MySQL, Aurora Postgres, and of course, NoSQL databases like DynamoDB and OpenSearch. And we can move data through various pipelines to various destinations. And let's review some of them. So first that we would like to discuss is the integration between Amazon Aurora MySQL and Redshift. So what's all about? What we are talking about? We currently providing this option to transfer data without any effort on your side to build or maintain pipelines in near real time from Amazon Aurora for MySQL to Redshift. And we can, when we have this data in Redshift, we can start analyzing it, run our models on top of it without any additional load added to our operational database. And the latency is a big question. We're going to discuss it in a few slides. So how we usually will tackle this, we will have our sources. We would like to have our data in analytical area, in Redshift. So usually we will build multiple pipelines, and we will have to maintain them and monitor them and secure them. And for this, we need resources, people, and investments. right? So all this is undifferentiated heavy lifting that your business is not benefiting from this. So we're trying to take this into and offload from you to us, and we will be providing this as a service. So it will be much easier to just spin up this integration between your relational database, Aurora MySQL in this case. We have this ability in preview for Aurora Postgres. So this one is coming soon. And it will be copying the data to Redshift. And this will allow you near real-time analytics on your production data without impacting your production database or any need to upgrade it or anything else. And of course, we aware that you may have more than one source of the data that you would like to analyze. So Zero-ETL can pull data from multiple clusters and ship it to Redshift without any additions that you need to run. So this will allow you to analyze large amount of data in Redshift and with all the benefits that come with this, including faster queries, analytic operations that will be much more sophisticated, and so on. So what we do, how we make this magic work. So we're trying to offload as much as possible of this toward storage layer. So our head nodes or writers or compute nodes are not busy with this. So we're utilizing as much as possible Aurora storage capabilities and Redshift storage capabilities. And we will be enabling enhanced bin logging on Aurora side. So we will be consistent in our operation. And we'll be capturing only changes that happened on Aurora and sending them to Redshift. And from tests that I was running in my environment, usually the data will be in Redshift in single-digit seconds. So the latency will be really, really low. And I think it's a great achievement. So of course, it may be different in your workloads. But because it's optimized and it's done mostly on storage layer, I hope that your workloads will be benefiting from this pretty the same way. Single-digit second latency between your production data and option to analyze it in Redshift. All right, so this is like example of what we see our customer doing with this solution. Let's imagine that we are a company that have multiple streams of data. Let's say data that is structured and data is not non-structured. And we have a lot of data that is streaming into Aurora, MySQL. And we have a lot of data streaming from streams, Kinesis data streams. Let's say we need to analyze both with low latency, and we'd like to have Redshift to hold them. So we can offload this from you towards Zero-ETL that will help you to ship your data from MySQL to Redshift with really low latency and without any need to build it or maintain it or monitor it. And of course, we will expose a lot of counters, so you will be able to see what's going on and monitor it and be aware of what's going on in the system. All right? So just again, to remind you, this is the integrations that are currently are there. Aurora to Redshift and Amazon DynamoDB to OpenSearch are available. The rest are in preview. Aurora Postgres is in preview. RDS from MySQL in preview. And DynamoDB to Redshift is in preview. So get out there, check them, see how they work. And of course, we will be really happy to hear your feedback because we're working on this. This is the project that we just started, and we have future for this. All right? Thank you. And now I will invite Aman to speak about NoSQL solution for this one.
Thank you. Am I audible? OK. So how many of us use DynamoDB already in our applications today? OK, I'm in the right room. For some use cases, my name is Aman. I'm a DynamoDB solutions architect. I've been with AWS for just under 7 years. I'm primarily focusing on the NoSQL technologies. Some of the customers that we see have use cases where they want to combine purpose-built solutions, purpose-built databases, right? It's all aimed at using the right tool for the right job. So for example, they'll have DynamoDB stored for their OLTP use case, right? That high throughput, low latency access. But they also need a lot of flexibility for certain parts of the data access. So maybe think about the Amazon retail store, right? We like to eat our own dog food. So think about the Amazon retail store. You go on the website. There is a search bar at the top. You start adding, start typing for products. So that could be pillows, that could be laptops, so on and so forth. And as and when you're typing, you see an autocomplete already, right? That cannot be powered by DynamoDB, unfortunately, but there is a purpose-built solution for that, which is OpenSearch, right? So OpenSearch can do your fuzzy searching, your analytics, your anomaly detection, your vector store, so semantic searches, and so on and so forth. So it is the right tool for that particular job. So we see customers using both of these stores together in cases where they need the fuzzy searching, the rich text search or the semantic search capabilities, but they also need the high throughput, low latency access. And this is also something that we use on the Amazon retail store, similar to these services. The other example where I've seen this being used is, let's say you're a retail store, right? And you have customer service on the desk in the shops there. And they want to look at customer profiles. They want to fetch a profile based on a customer standing in the queue. So the customer could give any information, maybe their first name, last name, their contact information, their address or what have you. And there may be mistakes in the spellings and so on and so forth. That's where you need OpenSearch. Because DynamoDB will do a string matching, basically. But if you need those rich text search capabilities, that's where OpenSearch comes into the picture. So because we've seen customers build this sort of pipeline where they keep the data in sync between DynamoDB and OpenSearch, we saw that, and based on that, there's a certain amount of effort that's required in order to make it possible. So this is sort of the pipeline that customers need to build, and I've built that myself. So it's really a lot of work if you look at it. I'll start with number one. So when you're first seeding your OpenSearch server, be it a cluster or a serverless domain, you basically need to take an export, right? A full data dump of your DynamoDB data, put that into S3, and then write an application that reads from that S3 data and seeds your OpenSearch service, be it a cluster or a serverless domain, right? With that, you have taken an initial dump, but what happens to the data that's incoming while you're doing that dump and load process? So for that, you rely on DynamoDB streams, which is number 4 there. DynamoDB streams is a change data capture stream of every change that happens on the table. So you see a record of what data changed, how it changed, and what is the target state of the data. So that can be consumed by a Lambda function, and that Lambda function can basically have the business logic and the code to basically ingest that data into the OpenSearch domain or cluster. So maybe if there's an insert, there is an update, there is a delete of a record in DynamoDB, that data needs to make its way through to OpenSearch, right? So think about a product use case, a product catalog for the retail website, where all the products are actually stored in DynamoDB, but you need to support that top search capability, right? And so you need OpenSearch to power that. But every time a product description changes or certain things in the product change, those changes are made into DynamoDB table, but you need that to replicate into the OpenSearch service, right? So this is the whole process that goes behind building such a data pipeline. Now, clearly, this is a lot of undifferentiated heavy lifting, and this is the word that you take home for the day because we've said it so many times. And so the Zero-ETL integration between DynamoDB and OpenSearch leverages an open source, secure, serverless technology called Data Prepper. And Data Prepper is basically, it's not something that's newly built. It's been there for years. We are running something around 2.7.0 release now. So it's out there, it's open source, it's secure, and it's also serverless. And so this is doing the ETL for you, where you do not need to think about the initial data dump, the export to S3, the chain data capture, the Lambda function, and all that goes behind doing it. So all of that basically unrepresented heavy lifting translates into just writing a YAML template. Right? This is the Zero-ETL integration between DynamoDB and OpenSearch. So I'll break, if you're not able to read it, I'll break that down into the E, T, and L phases, right? But as a whole, this is basically 26 lines of a template that will do the Zero-ETL for me. The first part is the extraction, which is taking the data from the source, which is your DynamoDB table. So here, I pass the DynamoDB table ARN or resource name, and I provide an S3 location where the Zero-ETL integration itself will do the initial data dump, right? And I can secure it with a particular role tied to a particular role and have permissions granted as per least privilege principle. The second part is the transformation. So this is where I can add certain transformation functions, right? The whole list is on the right. And basically what I'm doing here is I'm using two individual attributes, which is user latitude and user longitude, and combining that into a location attribute that the data prepper will add on my behalf in real time, right? So you can do a lot of stuff with anomaly detection. You can aggregate, you can compress, or you can add new data in it, right? And if you want to vectorize the data, you can also use a Bedrock connector on your OpenSearch server or cluster to basically vectorize that data as it is coming in. The final part is the load, right? And this is where I provide the target OpenSearch domain or cluster, depending on where you're doing cluster-based or serverless. And again, I can provide information about the index, where the data should go to. I can provide routes based on certain characteristics within the data, which particular index should that data end up in. And it's not just one cluster or domain that I can target. I can target multiple clusters of OpenSearch to index that data, right? And one of the key things over here is the document ID. Now, this is the unique identifier of the data in OpenSearch. And over here, the example uses a primary key, which is basically the partition key and the sort key of DynamoDB that you uniquely identify each and every record, right? So because we are also thinking about keeping the two data stores in sync, so whenever a change happens in the product in the DynamoDB data, it needs to be propagated onto OpenSearch, right? So the same product ID should reflect the new change that happened, right? So for that, we need the same unique identifier as we did in DynamoDB. So for that matter, we can just automate that process of creating a document ID by leveraging the metadata in OpenSearch. So when we set it up like this, data prepper goes to DynamoDB, gets the partition key and sort key attribute names, all the column names, combines that, and that becomes your unique identifier for the document ID in OpenSearch. Now, all of that undifferentiated heavy lifting or the whole architecture becomes much more simpler with just the Zero-ETL integration. So not only OpenSearch, but we see customers also, obviously leveraging the likes of Redshift for their analytics use cases. So a lot of times, again, data engineers would need to set up pipelines where they export data from DynamoDB, put that into, run some transformations on it, put that into Redshift, and then run their reports or their, analysis pipelines, basically. So for that, we've launched a DynamoDB to Redshift Zero-ETL integration as well. This is currently in preview, mind you. So if there are certain things that you see that maybe they're not great, let us know. We want to hear feedback. So basically, the thing that powers the Zero-ETL integration between DynamoDB and Redshift are incremental exports by DynamoDB. So DynamoDB supports incremental exports, which is basically you provide a start time and an end time, and it will return you all the data that changed between those times, right? So if you need the delta of changes, you can call it as many times you like, and you're only charged for the amount of data that's shared with you, not the whole data dump or the whole table data size. So what the Zero-ETL integration does here, it takes an incremental export roughly every 15 minutes, and then uses that output to ingest into Redshift. So you decide a Redshift cluster or serverless resource, and it will do the syncing between DynamoDB and Redshift. Now, this is the target table that's created for my integration that I was running. So it was an e-commerce table because Amazon. And so the schema of that target table is basically a partition key name, a sort key name, and a value column. So because DynamoDB is schemaless and it's a NoSQL database, the only mandatory parts of your record in DynamoDB are the partition key and the sort key, or the primary key as a whole, right? So a single item in that DynamoDB table can have, let's say, 5 columns or 5 attributes. The next item in the same table could have 200. So because of the schemaless nature, it's sort of tricky to map that in real time into a schema enforcing system such as Redshift. So the way it works is that we decide a primary key, same as the DynamoDB table in Redshift. So there's a partition key. My partition key name was PK. My sort key name was SK. And then there is a raw JSON value in the third column. That's the value column itself. So on the right is something that this is how the data would appear in Redshift. Now it is up to you to either use the same table that gets created automatically into your reporting pipelines, in your reporting queries, where you need to probably map the value JSON attribute as per your analytical queries, or you move this data from this particular Redshift table to your production table and sanitize it while you're doing it, right? So that's the work. The data is already there in Redshift. You either decide to update your queries to reflect to point to this particular table, or the table that you're already using, you basically move data from this table to that one. In terms of my test, and again, your mileage may vary, but basically I was loading the same e-commerce data randomized into DynamoDB, which was making its way onto Redshift. And so there was the CloudHouse metrics offered by this integration are basically include a lag between the time data was ingested into Redshift and the time it is available for querying, which was roughly about 20-25 minutes. So on the left, you see the lag there, which is pretty good if you think about your analytical database, right? Your data warehouse, basically. And on the right side is the data transfer, the raw bytes transferred. So there are many more CloudHouse metrics, not only for the Redshift integration, but also for the OpenSearch integration, which give you an idea of what was the time it took end to end. And that can help you, estimate whether it's good for you, whether you need it to be fast, whether it's too quick. Well, nobody hates things being too quick, but anyway. So I want you to take away from this session the capabilities of Zero-ETL, right? If you're data engineers, you're already maintaining data pipelines. There's a lot of effort that goes behind maintaining the code, setting up the infrastructure, maintaining that infrastructure, and maintaining the code again. So and making it bug-free is almost impossible, right? All of those things get taken away with the Zero-ETL integrations that are being supported for purpose-built databases. And so this can allow you low latency, high throughput, scalable sort of setup between your data stores, where you can use the right tool for the right job, but also extract insights in near real time. So these are the integrations that I want to put up again for you to take grasp it for a few seconds, these are the integrations that are supported. I did not cover OpenSearch to S3, but basically in the same YAML template that we saw, we can also add an S3 bucket where OpenSearch data will be dumped into. And finally, this is not the only set of integrations that are available. Well, not will be available. AWS is investing in a Zero-ETL future heavily, right? So if there's any other integrations that you, today set up data pipelines for, let us know. We're already in progress. There's a number of projects in progress that are integrating other database or other data sources. But the whole idea is that Zero-ETL is not going anywhere. It's only getting started. Feel free to reach out to us after the session or your AWS account teams if there are certain requests that you have about Zero-ETL integrations, about your data stores, and let us know. We'd love to learn. With that, I'd like to thank you for being here with us here today, and I would appreciate if you let us know how we did with the feedback. Thank you.